New weapons. Israel is using a strange kind of bomb in northern Gaza, leaving massive fireballs.
مشاهدينا، هذه صور مباشرة تأتينا الآن من شمال غزة لقصف إسرائيلي. كما تلاحظون هناك قصف إسرائيلي مكثف. نرى الصورة ونسمع صوت هذا القصف على منطقة شمال غزة. هذا القصف يأتي بعد عشرات الشهداء والجرحى في مجزرة بمخيم جباليا بشمال قطاع غزة. والقصف الإسرائيلي يعني أن هناك معارك على الأرض كما عودتنا الأشهر الثلاثة الماضية تقريبا من عملية طوفان الأقصى والعدوان الإسرائيلي الذي تلاها. القصف عنيف كما تلاحظون. إذن القصف متواصل على منطقة شمال غزة. القصف الإسرائيلي هذا متواصل في يوم ارتكبت فيه إسرائيل مجازر جديدة خصوصا.
Gonna do two quick demonstrations and then have a talk about what it is we just watched and how it might relate to plasma fire.
Today, I'm going to be doing something that may or may not destroy my microwave. To do this, all I need is to light a match and cover it with a beaker. Then I'll punch in 60 seconds and start cooking it. At first, it doesn't look like much is happening, but then it suddenly starts doing something kind of scary. This is all plasma, and it's basically just super hot, ionized gas. It's somewhat similar to fire, but much hotter and way more ionized. The moment the microwave turns off, it all disappears.
Did you know that fire conducts electricity? A flame is basically a volume of hot air and vaporized fuel. The heat of combustion tears some electrons away from their nuclei, partially ionizes the gas. This makes the flame an electrical conductor.
So the previous video shows that flame plus microwave energy equals plasma. This short video, I know the audio's bad, but what she's showing you is that flame is a conductor of electricity. My bad.
Did you know that fire conducts electricity? A flame is basically a volume of hot air and vaporized fuel. The heat of combustion tears some electrons away from their nuclei, partially ionizes the gas. This makes the flame an electrical conductor.
A couple of thoughts or ideas that I've had along these lines over the past 5 years is that maybe a regular fire is no longer even possible, that our environment is energized enough, like Ilana Freeland's book titled Under an Ionized Sky. Maybe our environment is so ionized or electrified that when you start a regular fire, that flame conducts the electricity up through the ground. Side note I want to throw in right here, systems like HARP are called ionospheric heaters, where they project the energy up into the ionosphere, energizing and electrifying that ionosphere. So when you use that too much, like Ilana Freeland's book says, under an ionized sky, when you charge the ionosphere so much, maybe it's what's gotten us to this point where fire is now turning into plasma because of all the microwave energy or the ionized atmosphere around us. HARP, High Frequency Active Auroral Research Program, also known as an ionospheric heater, and there's many of them all around the world. Or from within the air or wherever it comes from. And this was just a thought that passed through my mind because of the hundreds of fires that I pulled over and looked at, examining them for plasma fire burn signatures, aka electricity. one or two over the past 5 years. 1 or 2 fires where I was not able to spot the electrical burn signatures, plasma fire burn signatures. All of the others. So what's the chances? Like maybe a regular fire isn't even possible. What starts out as a regular fire, a flame, then conducts the electricity, drawing it towards it, turning that fire into a plasma fire. This also points toward the phenomenon that we've seen over and over and over, where the house burns to the ground and the trees right next to it are untouched, or a car is melted and right next to it is trees that are untouched. Because the car and the house are built out of metal, which is more conductive of electricity, and then once they start to flame, that flame becomes an added attractive element to draw the electricity toward the house. So I'll just use these as an example. The plasma lamp starts out like this, with all the little filaments dancing all over randomly, and then when you touch it, we're going to use this example over here because he's using his 5 points of his finger rather than his whole hand. The plasma tentacles draw toward these points, each one of his fingers. So that means there could be, that's a house, each one of his fingers is a house or a car. And it's drawing all the energy toward that house and that car, which is why the trees that are close to that house or that car don't burn, because all of the energy that would have touched that tree is more attracted to the car or the house right next to it. So around every burnt car or burnt house, there's like a 20 to 50 foot perimeter where the trees will not burn, because all of the energy is drawn toward that house or that car. Out in the wild, where a plasma fire happens and there are no cars or houses made out of that more conductive material, it chooses a tree, maybe the tree with the deepest taproot. Just like when lightning comes down from the sky and strikes the tallest thing, whether it's a tree or a building, when it's coming up from the ground, maybe it strikes the deepest thing, like the taproot of the tree. And once it finds the tree with the deepest taproot, it latches on and continues sending that electricity down that line to burn that tree. So now there's a 20 to 30 foot perimeter around that tree where the trees are not conducting as much electricity because it's already being drawn toward the path of least resistance toward that tree that's burning. So the flame also becomes an added conductor or attractive element. And that's how you can end up with one tree completely charcoaled right next to another tree that's barely burned. Or, as you can see in this image, this is an image from the video Fiery Sermon from the Valley of the Shadow. And on this tree, this isn't the only branch that's sticking out that is unburned. There's at least three branches on this one tree that show the same thing. Oops, maybe I can grab my pencil. Right here you can see there's clearly a fine line. If I could not mess it up. Like the energy is drawn back into the trunk of the tree and not allowed to flow out towards this branch that remains unburned. This branch remains unburned. There's a fine line right there. I don't know why it does that. So this idea that flame is a conductor of electricity, it's almost like it sucks the flame back into the trunk of the tree. Otherwise, if the flame was allowed to flow freely, as it was burning right here, turning this part of the trunk of the tree to charcoal, some of these flames would have gone up here and lit this other branch on fire. There's 3 examples on this one tree, with unburnt limbs sticking out from a trunk that's completely charcoal. So I don't think we're going to come to some great conclusion or understanding about plasma fire right now, but these 2 points are good to throw in your bag of ideas to be pulled out later on when you are able to establish some sort of greater conceptual understanding of how this works. Those two thoughts are flame plus microwave equals plasma, and that flame is a conductor of electricity. To that I would add, not only is flame a conductor of electricity, electricity is a conductor of flame, because fire is a weak plasma, it has an electrical element to it, and all electricity is attracted towards other electricity. Like it clumps together and it has a magnetic pull towards other electricity. Which might be why it sucks the flame back into the tree, because it's got this giant bolt of lightning going up through the tree. Am I still able to draw? Yeah. So any flame that would escape is drawn back towards the electrical current. This happens when electricity escapes the power lines. It'll jump right back into the power line as quickly as it possibly can, and it's searching to find a way back into the power line to get in with the flow and the main stream of electricity. When a little bit of electricity escapes and grounds, and it'll get right back into the power line. So maybe the flame is drawn right back into the trunk of the tree where there is the greatest flow of energy, and that's why the flame is not allowed to escape, and it produces these weird burn patterns. The other thing I would say is, if all you got to do is throw a match in a microwave and produce that plasma, and he says it burns a lot hotter than fire, why haven't we utilized that, like in your engine block? Maybe that plasma burns 10 times as hot as regular flame, so you'd only have to use 1/10 of the fuel. If you added a little microwave element to your combustion chamber, we could utilize that, and apparently we probably weaponize that, as we might have seen at the beginning of this video.